Hey guys, Mr. Gardner here. I'm going to go over the benchmark packet so you guys can check your answers and check your work and see what you did. So this first one is we're talking about solving linear equations and inequalities with one variable. So this has to do with a lot of times using distributive property and then using your inverse operations to solve. So this first one says, which line holds an error in this problem? So if we look at the original equation, then we know to start out that we need to distribute the 4 times 22. So we need to distribute this, and then we need to distribute it here as well. So if we were to do that, we would rewrite that step as 118 plus x is equal to 4 times 22 is 88 minus 4x. So we look at line 1, and it says 118 plus x equals 88 minus 4x. So we did that right. We're confident. So that means line 1 is correct. It's not incorrect. The next thing we would do if we were looking at this is we would try to move this x over so we could have x's on one side. So if it's plus x, inverse operation tells us to subtract x. So that makes 0. We get 118 equals 88 minus 5x. Now again, we look. 118 equals 88 minus 5x. So line 2 is correct. It's not incorrect. Okay, because again, we're confident in our work. So again, we want to look. This kind of gives us an idea of what's going on. And we can see here, we've got this constant. We need to get rid of it. So we're going to subtract it from both sides. Okay, we're going to get rid of that here because that makes 0. And 118 minus 88 gives us 0. And 11 minus 8 is 3. And that's positive equals negative 5x. That's what this step shows. We're confident in our work. So then we know line 3 is correct. It's not incorrect. So then that only leaves us with D. There's no incorrect part to this. But let's just check line 4 anyways. Divide by negative 5. Divide by negative 5. And we would see that that becomes just 1 because anything divided by itself is 1. And we get 1x is equal to negative 6, right? A positive divided by a negative should give us a negative. That's what this shows, which means there's no errors in the problem. Okay, let's look at these next problems. So this one, again, it's asking us to do a little distributive property. That's where we're building that fluency that we can just see it right away. And we can do this math right away because we should be fluent in this kind of multiplication. All right, and again, now we have two expressions, right, set equal to each other. We want to isolate the variables on one side and isolate the constants on another side so that we can solve the problem. So to do that's not so bad. I like to just do positive numbers. For me, it just is simpler. So I'm going to subtract 2x and subtract 2x. That's going to give me negative 16 is equal to 10x minus 72. Then I'm going to add 72 to both sides. So that becomes 0. I'm just going to move over here as I get 10x is equal to, remember when I have a negative and I'm adding a positive, then I just subtract the smaller one from the bigger one. So I get 72 minus 16, and I'm going to keep the sign of the bigger one, which is positive. So I take away from here, I get 6, 12. 12 minus 6 is 6. 6 minus 1 is 5. And it's positive, so that's 56. Now I divide by 10. Divide by 10, and I get that x is equal to 5.6. Again, you can check your answer by plugging it in to the problem and seeing if your result comes out correct. Here, we're going to do the same thing. We're going to distribute. Again, we want to pay attention now. We have an inequality symbol. So we have 2x minus 14 is greater than negative x plus 13. Now, one thing you want to remember here is if any part of this problem makes it where you have to divide by this negative, then you're going to have to flip that inequality symbol. So again, when I'm looking at how to do these, I think about that. And I think if I move this one over, I don't have to divide by a negative. And that's going to just save me a step. So I'm going to move the x over first on this one. So now that gives me 3x minus 14 is greater than 13. Now again, I have all my x's over here, and I still have a constant and a constant. So I want to move this over, so I do the opposite. I'm going to add 14. And again, you can see I've kept now positives on both sides, so I don't have to worry about that flipping of the inequality, which is a really easy step to forget. Divide by 3. X is greater than 9. Bless you, Mr. Gardner. Thank you, Mr. Gardner. All right, so let's look at the last one. Last one, we don't have to do any special distributive property or anything, but we do need to combine the terms that we can. So we get -2 is less than 4p plus 10. That's just combining those two. Now I'm going to take away this 10 because I want to keep my p's on this side. So -10, -10. Again, remembering, I got a negative and a negative, so I'm going to add those and keep the sign. So I get -12 is less than 4p. This is really nice because I don't have to divide by a negative, so I don't have to flip the inequality. So divide by 4, and I'm going to see that this becomes 1, and I end up getting -3 is less than p. Now, I always like to say to put this in the letter first, so this should be p greater than -3. That's because when you go to graph it, this inequality symbol, if the variable is first, is going to tell you which way to point your graph. Now it's open circle because open circle is for greater than or less than, and a closed circle is for when there is equality. So I don't have equality, so I'm going to do an open circle. It's going to be on -3, and this is going to tell me that my arrow should point to the right because I'm greater than -3. This says the same thing, you just don't get that hint from the arrow when it's in this order. All right, so that's just a little trick. All right, number 5. We're now at finding rate of change, finding slope. And if you remember, when we're doing that, we want to just look at the rise over the run. So we want to see here that the profit is 7 or 15. So we go up here, we go up 15 and over 2 to this point. So we can see that we rose 15 as we ran 2. So that tells us we have 15 over 2, which is our rise over run. And if we're going to do it out of, this says for each car wash, but we wash 2 cars. So we know that's not going to work. So if we put it in terms of 1, we know to get here, we divide by 2. So I'm going to divide the top by 2. That's going to give me 7.5. And so I can see that right here, we have $7.50 profit for each car washed. All right. And you can see here, it wouldn't be 30 because here's 30 and that lines up with 4. So it's not $30 for every 4 cars washed. And then you can see also 4 isn't 45. So this one's not going to work either. So this one's close, but not quite because this is 2, not 1. 1 would be here. And there's that 7.5 mark. Okay, again, when we're looking at these, find the rate of change. Remember, we always want to do the change in Y over the change in X, right? We want to do that rise over that run. All right. So we can look here. The change here is +4 and the change here is +2. So that tells us we have a 4 over 2 or 2 over 1 situation going on, right? So we have 2 inches of height to every 1 inch of width. So that's going to give us D. Okay, the cost of paper varies directly with the number of reams bought. Suppose 2 reams was $5.10. Write a linear equation that could be used to find the cost of X reams of paper. Find the cost of 15 reams of paper. Okay, well we know that if 2 costs $5.10, then that's 510 divided by 2, and we want to know what the cost of 1 is, so we can write an equation. Okay, so again, we don't know this value, so we can find that value either by cross multiplying and dividing or just dividing. And so we get 510 divided by 2, decimal, decimal. 2 goes into 5 2 times, 4. 5 minus 4 is 1. Bring down our 1, it's 11. 2 goes into 11 5 times. So we get 10, we get a 1, bring down to 0, we get 10 again, 255. So our equation is cost is equal to 2.55x, right? Because x is the number of reams. Okay, so if we're doing 15 reams, then this is just cost equals 2.55 times 15. So we just got to do the math. Remember, we have 2 decimal places, so we just take note of that so we can put those back at the end. 5 times 5 is 25. 5 times 5 again is 25 plus 2 is 27. 5 times 2 is 10 plus 2 is 12. Okay, put in our 0. 1 times 5 is 5. 1 times 5 is 5. 1 times 2 is 2. Add these together. Okay, we got to bring in 2 decimals, so 38.25. So that would equal 38.25. And that should make sense, right? 2 of them is $5.10, and this is about 7 times more, so this number should be around 7 times more than 5, which is 35. And so it should be a little bit more than that because it's more than double. All right, so this one's, we want to compare these two functions. So which function has the biggest rate of change? So again, for these, we want to do our rise, which is +2, over our run, which is +2. So for this one, our m is equal to 2 over 2, okay, or 1. And on this one, we can see our rise is going up 2 over 1, so +2 plus 1. So this one, our m equals 2 over 1, or 2. So which function has the greater rate of change? Well, that's going to be function 2. Which one has the lowest y-intercept? Well, we know here the y-intercept is 0, 0. And here it's where x equals 0, it's 3. So this one's lower, so that's also going to be function 2. And which one shows negative slope? Well, this one's going up. And if I graphed this one, 0, 3 would be here. 2, 5 would be there. So neither one of them has a negative slope. So neither. All right, number 11, Beth is joining a gym. Her registration fee is $100, so we pay that once. $25 per month. This tells you that this is the one that's changing, and this is our variable. Okay, Jamie joined a gym, $50 for her fee, so there's our one time, and $40 per month. After 1 year, who pays the most? So what you want to do is you want to make an equation. So we know that the cost, so we'll say cost, and we'll call this one Beth. So we'll cost of Beth, and we'll do one that's the cost of Jamie. So the cost of Beth, right, is going to be 100 plus $25 times months. And for Jamie, it's $50 plus $40 per month. And again, you got to do a little conversion because 1 year. So 1 year is equal to 12 months. All right, so then we're just going to put 12 in here so that we can do our comparison. So 100 plus 25 times 12. And that's going to give us 100 plus, what's that going to be, 300? So this is going to be 400. And let's look at this one. So we have 50 plus 40m, so 50 plus 40 times 12. And that's going to be 50 plus, what's 40 times 12? 480. And then we put those together and we get 530. So this one equals 530. So who's got a better deal? I would say that Beth has the better deal. All right. But she pays a little more up front. So it's something you just want to look at. You know, people try to trick you. Maybe you think paying more up front is going to be worse. So you switch to a place that lets you pay cheaper, but they end up getting it back in the monthly fee. Okay, now let's look at these ones. And let's see if we can figure out which one of these represents the equations in the list. So again, the best way to remember this is that our function is y equals mx plus b. And we can find that from our table. So we know right away that the b value is when x is 0. So our b is -4. So right off the bat, this is no good, this is no good, and these two are good. So then next we want to find m. And we remember that m is the change in y over the change in x, which is rise over run. So now we want to look at this. The change here is +1, and the change here is +1. So 1 over 1, 1. Okay, so again, it's not negative, so this is no good. So the only answer that works is D. All right, which linear equation represents the graph? So again, we're looking at this. We can see that which way it's going downwards. So that means it has a negative slope. So right off the bat, we can get rid of the 2 positive slopes. Okay, the next thing we can look at is it goes through at 1, and it goes through at +1, which is the intercept. And this says -1, which would be down here, and it doesn't go through that point. So this answer is no good. So my only answer that works is C. Okay, lastly, or not lastly, but the next one. Logan has $9.50 in his bank. Every month he spends $75. He does not add money to the account. Which equation represents the situation? So spending, do you add money or do you subtract money when you spend it? You subtract, so that's negative. and here's our starting amount, which is a positive. So we already know from here that the negative 950 is not going to work on either one of these. So we have to think, is he spending money or is he getting money? This says he spends it, so A is our only answer that works. Number 15. So number 15 is just showing us these same functions, but as a coordinate pairs. So you can put these in a table, and then it might be easier for you to write the equation. So in the table, you've got negative 6, negative 11, and then 2, negative 5. So if you look at this, if we're going to do rise over run, so we can find slope, then we're going to see that this is plus 6, and this one here is plus 8. So then we know our rise over run is 6 over 8, or we could also call this 3 over 4, okay? Or if you want to do it in decimals, this is 0.75. Then we have to find the B value, right? Because this is our M value. So now we got to find B. And we know we can find B by inputting one of these values. So if we know that we have Y equals MX plus B, and we know M, so Y equals 3/4 X plus B. And we know an X and Y value because it's just one of these pairs. We can choose either one. Let's just choose this one. Then we can find our B value. So now we get negative 5 equals 3 over 4 times 2 plus B. So now if we do this math, we know this is 2 over 1. We just multiply straight across, and we get negative 5 equals 6 over 4 plus B. And now we have to think about how we can solve this. So we know if it's being added, then we subtract this 6/4. So minus 6/4. Minus 6/4. And again, we can't really subtract this because of the way it's sitting right now. So we're going to have to find a common denominator, but this is 0. So we get B is equal to negative 5 minus 6/4. Okay, so we got to find the common denominator, which is this is over 1. Then we just multiply this one by 4, and we keep the 4 as it is. So we end up getting that it's negative 20 over 4 minus 6 over 4. All right. And then we can see here that if I just make this plus a negative, then we get negative 26 over 4. We get negative 26 over 4. And so that's going to be, if we reduce that down, that's going to be what? Negative 13 halves. Okay, so then if we go to rewrite our equation, we get y equals 3 over 4x plus negative 13 over 2. Or 3/4 x minus 13 halves. So that's how you do that one. Number 16, the graph of a linear function is a linear line. D, line. Which scenario does not represent a linear function? Okay, remember, linear doesn't have any exponents greater than 1. So $50 a month and $25 per text. That's linear, right? There's nothing being exponentially changed. John rents a rug doctor $30 and $5 each day. Okay, that's linear. You buy a printer, $100, and the ink cartridge are $25 each. Linear, again, nothing's exponentially changing. A baseball is hit into the air at a speed of 90 miles an hour. The equation for the ball's height is function equals negative 5x squared plus 38.7x plus 25.5. So there's that exponent that's greater than 1, so that means D is not linear. Looking at these last 4, again, if it's linear, it's a line. So you're looking for a line. Is this a line? Yes, linear. Is this a line? No, that looks like a hook. So non-linear. This here, straight up and down, that's a line. And this here is horizontal, that's a line.